I am going to now give a simple example of calculating portfolio returns and risk with our formula. Here are our formula. And again, expected return of our portfolio equals the weighted average of the returns of the two assets in the portfolio. The expression for the variance of the portfolio is a little bit more difficult, but the standard deviation is the square root of the variance. So those are our two formulas. Now let's apply them. I'm going to apply them to this case. We have two assets. One has T-bills. Asset 1 has an expected return of 4%, standard deviation of 6%, stocks 11%, expected return, standard deviation of 25%. We're going to assume they have a correlation coefficient of 0.8, and we invest 0.4 of our portfolio in asset 1, which means 0.6 of it is in asset 2. Given that our expected return, again, is a weighted average of the two return, or asset 1, asset 2, 40% of the weight on asset 1, 60% on the weight of asset 2, we come up to an 8.2% return. Variance, you see the formula there. We square the weights in the first two terms. We square the standard deviation in the first two terms. And the two W1, W2, you see it applied there. All right, you come up with a variance of 0.028836. Square root of that is 0.17. All right, just an example of applying the formulas. Just a note, as we change the weights, if we get that weight closer to 1, we're going to look more like asset 1, which in this case is lower return and lower risk. And if it gets closer to 0, which means we have much more of our portfolio on asset 2, it's going to look much more like asset 2. In fact, if we have 0% in asset 1, it's going to look exactly like asset 2. You can confirm that with those formulas. One other point. Let's just look at the correlation coefficient. Again, you cannot change that. That's a number that is known, or not, maybe not known, but you don't change that. But this illustration just shows what happens to the portfolio standard deviation as you change the correlation coefficient. If we have a correlation coefficient of 1, we have a portfolio of standard deviation of 1 or 0.174. That happens to be the highest that it can be given the weights that are in the previous example. Lower it and the portfolio standard deviation goes down. Our risk efficiency increases with lower correlation coefficients.